Good afternoon, ladies and gentlemen. Joining us here in the lecture theatre, as well as those joining us online through WebEx. Welcome to the dialogue session on ethical and societal implication of IR 4.0. On behalf of the organizer, thank you very much to all for taking off some time to join us today. We really appreciate it. I'm sure we can learn a lot from today's session and hope what is lined up to be fruitful and engaging. And those just came in, please make yourself comfortable. Okay, guys, I would like to start the dialogue today by introducing to you our moderator and the list of panelists. So first, please welcome on stage our moderator for today, Dr. Nishata Royan from School of Engineering. Dr. Nishata is a highly motivated and passionate lecturer in School of Engineering UOWMKDU, University College, Glenmary campus. She obtained her bachelor, MSc, as well as her PhD from UKM. She is a research-driven academician where it aligns with her self-identity to keep challenging herself and exploring new materials. Her research expertise is in natural fiber composite, rice-husk technology, polymer composite foams, nanocomposite, and actively venturing into additive manufacturing 3D printing research. Now, for our first panelist, we are honored to have all the way from Australia. Please welcome Professor Gursel Alisi. Professor Gursel Alisi received his PhD degree in robotics from the Department of Engineering Science, Oxford University, Oxford, UK in 1994. He is currently a senior professor at the University of Wollongong, Australia, where he holds the position of Executive Dean for the Faculty of Engineering and Information Sciences. His research interests are soft robotics, system dynamics and control, robotic drug delivery systems, novel actuation concepts for biomechatronic applications, robotics mechanism and manipulation system, soft and smart actuators and sensors, prosthetic devices, and medical robotics. And our next panelist is no stranger to the School of Engineering in Glenmary campus. Ladies and gentlemen, give a big applause to IR Chiang Kok Meng. So IR Chiang obtained a bachelor degree in electronics engineering from University of Western Australia. And he also had a master degree in business administration. As you know, he's a professional engineer with a practicing certificate from BEM. His current passions are in the areas of philosophy, sustainable lifestyles, and social technology. And also joining us from Penang campus is our third and last panel for today, which is Associate Professor IR Dr. Gomesh Nair. Dr. Gomesh is the head of Postgraduate and Research Center at UOWMKDU. He has more than 10 years of management, academic and research experience serving public and private institutions. He obtained his PhD in 2015 from University of Malaysia Perlis in the area of solar cell fabrication. His research interests include the field of dye-sensitized solar cell, multi-level inverters, electrical machine design, data science, and analysis. Okay, without further ado, now I will pass the dialogue session to Dr. Nishata for the rest of the sessions. Thank you very much.
Okay, thank you, Ms. Salina, for the short and precise introduction. Our Honorable Prof. Gursel Alisi, our very own IR Chiang, our Penang representative, Dr. Gomesh, all our fellow colleagues from SOE, all virtual participants, fellow students, welcome to the dialogue session with Prof. Gursel Alisi. Today's topic is the ethical and societal implications of IR 4.0. So ladies and gentlemen, Nowadays, everyone is keep talking about IR 4.0. So what is this IR 4.0? So to break the ice, maybe we can call someone from the audience, from the students. Okay. So what you think about IR 4.0? Okay. Any students? Yes. So maybe you can introduce yourself from which department first? You need to.
Hello, hello. Okay. Right. Hello. Okay, thank you. Hello, my name is Andrew Leong. So I'm from the School of Mechanical Engineering. Okay. So in my opinion, IR 4.0 refers to the fourth industrial revolution, which focuses on the incorporation of cyber-physical systems, automation, and real-time data. This all includes things like Internet of Things, smart manufacturing, and also artificial intelligence. That's all from me.
Okay, thank you. So that is what he defined. I think he took it from Google, right? Okay, now moving back to our panelists, maybe our counterpart from Penang, Dr. Gomesh, how do you define IR 4.0 in education perspective?
Thanks, Dr. Nishata. Can you hear me?
Yes, yes.
All right. Yeah. Okay. So looking at industry, for example, so when we define industry, it's like a process of making raw material and manufacturing goods and services and all that. But when we talk about education industry, so basically what are we producing is actually students, skillful students. We want to enable them, empower them, give them diverse knowledge, expertise, and so on and so forth. So basically, if you look at education perspective, there is, I know that the key term now is education 4.0, just to match with IR 4.0. But there is no such thing as education 1.0, 2.0, 3.0, and so on. So looking at education 4.0, basically what it wants is it wants to respond to industrial 4.0, where they want to make the man and the machine align. They basically harness potential, digital technology in education. So basically education, or I should say education 4.0 is expected to align with industry 4.0 in terms of making sure that the student meets with the job requirement. The student is given knowledge on certain technologies, be it like, artificial intelligence, supply chain, additive manufacturing, all these things are the pillars in industry 4.0. And as in an education institution, we are expect to provide the, lifelong knowledge to the student and keep abreast with all this technology in or under the umbrella of Industry 4.0. So I think by definition, that is how they view it, Education 4.0 as. Yeah.
Okay, thank you, Dr. Gomesh. So our very own industrial expert here, IR Chang. So from the industrial aspect, how do you define IR 4.0?
Okay, thank you. From the industrial perspective, maybe I should take it as based on a hint that Dr. Gomesh has said in education, you don't have 1.0, 2.0, and 3.0. So perhaps it's best clarified from the industrial perspective using the historical method. I mean, 1.0 is basically about mechanization, right? It's about machinery. Of course, mainly steam powered and stuff like that. 2.0 is about the electrification. We have got electrical machinery, right? 3.0 is about automation and digital techniques. Those things makes things work on their own, right? So what is 4.0 is the latest advance. Is not only can our machinery do things on the own. To me, I know the opinion actually differs across all sectors. To me, it's all about intelligence. Today's machinery are able to decide to a large extent what they should and should not do, right? So today's systems and technology is what I would call intelligent, and intelligence to me mark the what is IR 4.0. Yeah, but I'm not sure about the. As I said, opinions differ.
Okay, thank you, IR Chang. So now, Prof, you have your final say on this. So how do you define IR 4.0, maybe in a global aspect content, please?
Microphone? Okay. First of all, thank you very much for inviting me. And I'm very happy to be here today. Somehow feel very connected with this campus, with UOWMKDU. Maybe it's my first trip to this campus in 2019, November. If you were around, I don't think students were around. There was a conference here on prosthetics and orthotics, an international conference. So I was asked to come and give a talk. I was in Canada at that time on sabbatical leave, and I happily accepted. It was a very wonderful trip. I met some of you, most of you. I could see the energy, the potential, the connection, student staff who want to do their best, and to move forward, to make a difference in the life of students. And I can see how important education is for you, for Malaysia as well. Education is something you can take. It's individually. Nobody can prevent you taking it. It's in your hands. Of course, opportunities and resources can be limited. But as individuals, if you want to move from where you are to the next level in terms of opportunities, prosperity, to see the world with a wider angle. So education is to see the world maybe like this and then and opening new opportunities, a confidence in moving forward. This is for individuals. The same thing is for the countries. There is a famous phrase called education builds a nation. I think it's very important for developing countries like Malaysia to get out of where it is now, to develop status. You have to have educated workforce. And that's also important for the governance of the country, for management of pandemics. Remember, during the pandemics, if we all had the same understanding of how to deal with it, I'm sure we would have got out of that one earlier. So education is a tool, a way of thinking, looking at the problem with a wider angle. And it's something very important. So that's why I had this connection, this potential somehow from my inner side, saying that somebody who is trying hard, who is trying to get out of where they are, motivates me to be here and to support you, to help you, to guide you. So engineering is one of those professions, building things, making a huge difference in the life of people. If you want to increase the quality of life, you have to make things, you have to build things, you have to solve problems. So in that regard, I have a very special connection here. I'm very happy when professors ask me, would you like to meet our students and staff? And I said, yes, I am happy. They said the topic. I didn't select the topic. I said, that's okay. I can speak lots of things. We academics tend to speak a lot, but hopefully I will talk meaningfully. So this is introduction. About Industry 4.0, as my colleague mentioned, we have 3 revolutions before. They were revolutions. And every revolution creates its conditions. You have to create its condition. You have to have enabling technologies. As Andrew, I think was your name, Andrew? Yeah, Andrew, that's it. Well done. And he talked about some enabling technologies, artificial intelligence, cloud computing, simulation, automation, data science, artificial intelligence, virtual reality. What else I can think of? Big data. I think I talked about big data, autonomous robotic systems, automation, assembly, horizontal and vertical system development and assembly. There are around 9 enabling technologies for Industry 4.0. In a way, you have to name it. That's why in 2011, Germany, which has a very strong manufacturing base, and from their products, German engineering is top. They follow all the standards set. In 2011, they announced Industry 4.0. It's all about using these enabling technologies to create or to have more efficiency and productivity in manufacturing. So it's all about productivity and efficiency. So that's how Industry 4.0 was named, is being around, and some advanced economies were using automation, artificial intelligence, decision making, cloud computing, Internet of Things, they call it. Internet of Things, at the end of the day, you have a network of sensors which collect the data, and then you use artificial intelligence to make a decision. When to, for example, maintain a machine, or when to change, to make a decision about product, supply product. You see, and so Industry 4.0 is about mass customization. Industry 4.0, as my colleague mentioned, is Industry 3.0 is mass production, mass fabrication. Now is mass customization. You can customize. Of course, as Andrew said, another thing is cyber physical systems. You should be able to join other facilities and infrastructure in the same country. You don't need to have a milling machine or computer controlled machinery in every state. You just design it, you email it overnight, and they download it to that machine, and you fabricate, perhaps you distribute to where it is. So that's why Industry 4.0 is a kind of, you have to have conditions. You can't simply declare revolution. Revolution is a very dangerous word. In some countries, they are going to jail you. So some people call it evolution, but it is revolution in the sense you have to create conditions. The conditions are the enabling technologies. And it's manufacturing as well. So that's another enabling technology. Your area, I forgot, I'm sorry. So these are the conditions. Industry 4.0 is all about efficiency and productivity using those enabling technologies. This has been 11 years. And in 2021, same Germany, I think in Sweden, they talked about Industry 5.0. Industry 5.0 is not like previous revolutions. It's something, it has to go together with Industry 4.0. It's not like, oh, Industry 4.0 is completed, now Industry 5.0. It is something which has to go next to Industry 4.0. But it was announced after COVID-19 because in Industry 4.0, somehow they ignore the human component, resilience, human-machine cooperation and collaboration. They try to leave the operator out of the fabrication. But COVID-19 taught us something. You can't ignore human factor. You have to be resilient. You have to have the social aspects in what you are fabricating. So Industry 4.0 and 5.0 are in parallel. Industry 5.0 is not the replacement of Industry 4.0. Okay, so these are, it's like even some experts says is more technology-driven Industry 4.0 is making about, but Industry 5.0 is value-based to connect with people, to value the workers, to value the workforce, their well-being as well. So well-being of the workers is also important. We saw that one during COVID. You can't rely on machinery all the time. Once the power is cut, it's cut. So I think it was like a wake-up call for Industry 5.0. Please don't think that Industry 5.0 is the replacement of Industry 4.0. So Industry 4.0 is the name to use those enabling technologies according to Boston. I think it's a consultancy company, Boston Consulting Limited. There are 9 enabling technologies. I think I try to remember all of them. Once you bring all of them together, you just named it that the governments, universities and industry can work together and support together to increase efficiency and productivity. But while doing this one, my colleagues, if I call you, you will be my colleagues when you graduate, it has to be environmentally responsible. You can't, maybe I'll come to that question later. You can't ignore environment. You can't ignore air quality, water quality, damage to the environment. It has to be socially responsible at the same time. You make sure that you spread the wealth across the society. I mean, it doesn't matter how rich you are. If your neighbor, your relatives are not well enough, they can't find food and meet their basic needs, there is no need of having such prosperity. So the technology should bring prosperity to whole community. Then we will have a peaceful community, socially safe and happy community. Lastly, of course, it has to be business sustainability. See, if you are running a business, you have to have profits and expenses. Like all of us, I mean, you got a salary, you got expenses. If your expenses is above your salary, you are not sustainable. You are in debt. Maybe for 1 month is okay. So the same thing with business as well. So when we are having these technologies, Industry 4.0 now we are talking about, it has to be sustainable from those 3 points: environmental, social, and business as well. Maybe I told too much, but it's an enabling, it's the name. You bring those technologies together to increase productivity and efficiency. But when it was announced, the human factor was a bit ignored. So Industry 5.0, thanks to COVID-19, humans have to be in the center of any innovation, any industrial revolution. Hope that summarizes.
Thank you, Prof. Thank you, Prof. So I think now all of us have a better understanding on what is IR 4.0. Okay, Prof. Actually, we are very curious to know on your research background and how is it related to IR 4.0 and how it will impact the society.
It's written there. I did my PhD in robotics before some of you were not born. I think it was 1994. I completed my PhD in robotics. My PhD thesis was about robot force control to make holes in some experimental boxes used in nuclear energy, in nuclear research. So the idea was to use the robots to make a hole and then use a saw to cut those nuclear boxes into smaller pieces. Then the robot can take those pieces, put into some steel containers, and then move and then bury underground. So it was sponsored by Harwell Nuclear Research Labs in Reading, in England. So my supervisor had a project from there. But more important, the idea was at that time, giving robots sense of touch, haptics. That was one of the most important research topics. I'm afraid it's still important. I'm very surprised that still commercial robots don't have sense of touch to control how much force that they are applying to the environment. So that's my area of expertise. Since then, I worked on parallel robots, system dynamics and control. Recently, I'm leading a research program in Australia, sponsored by Australian Research Council, called Soft Robotics for Prosthetic Devices. So the idea of soft robotics is to make robotic systems primarily made of soft and hard materials, but primarily made of soft components, such that when those robots interact with people, with the external world, you don't have to use a very advanced controller, use the softness in the robot. It's like, like us, our hands are soft. If you make a mistake, you don't break your finger or whatever you are touching. The same thing with the robots. But classical robots are rigid machineries. That's why I did my PhD in robot force control. So that's the connection between force control and soft robotics, which says use the material properties to control the interaction between the robot and the environment, especially in medical devices, rehabilitation devices, when humans are in the loop. So when the machine makes a mistake, it doesn't hurt because you got softness, like a cushion, Think of you are sitting on these wonderful chairs. If you are sitting on the wood, I don't think you are going to sit for a long time. While your flesh is soft, but what you are sitting on is not soft. That's why it's made soft. Soft on soft is fine. But when you make soft on hard, it will not last long. So the same thing. So this is my area, soft robotics. And we work on also, I did some research projects on robotic drug delivery systems. We have some patents. If you go to LinkedIn, I'm sure you are searching my profile in LinkedIn. We applied for 3 patents. We have 3 patents on, actually, I have one in my bag, luckily, those robotic capsules. Maybe I'll bring it. Can I bring it and show? Well, I'll go there. Sorry, I'm just telling you what my areas are. I'm here just to answer your questions. And thank you. That's very kind of you. Let me find the capsule in my bag. I think I saw one before I was packing. I was going to take away. I said, okay, I will. So it's this one. So these are capsules. They are called endoscopy capsules. Actually, they are currently being used. Patients swallow these ones. It's like a vitamin pill, but this does not melt. It has a camera. The new ones has 2 cameras, one at this end, one from other end. And it has a disk type battery inside and the wireless system. Wireless, it transmitter, it records, it's a camera, yes, the images. And then you have a receiver around your belt area when you swallow. And it takes pictures according to the time set by the surgeon. Every 10 milliseconds, every 0.5 seconds, or every second. As soon as it drops into your mouth, it takes 8 to 10 hours, depending on what you ate. And it goes to the other end. So by the way, this was not used before. Okay. So these are being used, invented in year 2000, but these are passive. When you swallow, you don't know where it's passing through. Maybe in your small intestine, there is an area of interest which didn't show you. Current wired endoscope or colonoscope, they are called. They can either go through your mouth or through your bottom, but they can't access everywhere in your GI tract because there's a limit. You can't push further. So there is an area in between they can't touch. But this one can go through from your mouth to the end, seeing everywhere. And doctors get this data, download on their computer. They have a software. Then they identify the areas of interest, saying that, hey, in your small intestine, I think there is an area, black, dark, whatever. We need to get some biopsy. If it's identified, diagnosed, deliver a drug. So what we did between 2000, when did we start? 2012, 2018. If you look at our publications, I had 3 PhD projects. One was to put a magnet inside and put some screws outside and apply a rotational magnetic field to move this one in the intestine. I mean, this can be a topic of seminars later. So the idea was to move forward, backward, or stop it. We can control it like a robotic system. Yeah, I got some videos. Anyway, maybe I showed of that one. The second PhD was about stopping this one in the intestine because our body has an effect called prosthesis. All the time is pushing forward. It takes 8-10 hours to push to the end. So you need to stop it. So we call anchoring. And one of our patents is on stopping this one when it comes to destination. So we invented a technique like an umbrella, like the umbrella legs, you know. You push it, but you can't do it. It's very limited. All you have is this. Where is the battery? Where is the mechanism? So we used, again, magnetic theory, magnetism. We had a magnet here. And when we apply the magnetic field, it turns, opens the legs to anchor inside like a tunnel. And then it stops there. That's our second patent. And then from there, you can move around to get more images from the cameras, zoom in, and also get some samples or deliver drug. So third patent is we build a spherical one. This is cylindrical. We made it like a sphere. It can roll. Then two ends has two needles, but the needle should not be too long. Otherwise, we are going to make a big hole. So it was only 2 millimeter stroke to deliver drug to the location. So that's our also patent. If you look at, I think in the LinkedIn, there should be some details and some publication. So that's another area I led, but we didn't find funding. That's that one. Shall I say more lastly? Anyway, so it's my work is, I think, at the center of those enabling technologies, not all of them. Robotics, automation, we use machine learning a bit, additive manufacturing, sensors, actuators, and all this. So I believe somehow I'm lucky that
the topic is related to you, right?
Yeah. Anyway.
Okay, that's so cool. Thank you, Prof. That's so interesting. Thanks for your sharing. I just wondering what kind of material is that? Since I'm material background.
This is a kind of plastic, of course. I'm happy to send around by the guys. And don't swallow. I'm happy to share.
It's made of plastic.
Yeah, it's plastic. It's glass. Yeah, please. It's clean and it's...
Okay.
No.
All right. Thanks.
I mean,
thanks.
as I said, please don't go and have a look at some of the publications. If you put my surname and you can see some publication of robotic capsules for drug delivery, for anchoring, for actuation, and published in various journals, you can see what I'm talking about. So it's all about bringing, you see the same thing in research, friends, colleagues. You get this expertise, you apply to another problem. So I did my PhD in robot force control. And I know how to solve a problem, how to describe a problem, how to report about a problem, how I see the problem. So the same thing for you, my student friends, colleagues. You can't learn everything here. We can't teach you everything. Impossible. I mean, before 2011, nobody was talking about Industry 4.0 or, I mean, it was there. It wasn't at that level to declare as part of the revolution. You have to be confident. You have to remember, since high school to the end of your degree, what you have achieved. You didn't know anything about engineering. And in 4 years or 3 years, what you have learned and achieved should give you confidence, should give you a mindset that, look, I can solve almost any problem. I think you should say that. The approach more or less is the same. You need to, of course, have to have some knowledge. You have to have fundamental knowledge. I'm not saying don't have any knowledge. Just be a stupid guy or person saying, I know everything. No. You need to accept that you don't know everything and go to library, go to online and whatever, read about problem first, understand it. So you need to understand it first. As Einstein said, if I give you 1 hour to solve a problem, I will spend 50 minutes or 90%, he says, on understanding the problem. So you need to have this mindset. Don't expect that my colleagues here in Australia, at the best university in the world, are going to give you a recipe you can apply to everything. Techniques are not going to change how you approach, how confident you are, how you use critical thinking, how innovative you are, how humble you are, except you don't know it. And go and sit down, ask for extra time. Try to understand and try to find solutions and then report about it. And you will see that gradually you will have those kind of confidence and you will be moving from project to project, solving some challenging problems. So I can see this problem in many countries saying that, look, university should teach me all elements of Industry 4.0. They can't. We got 9 enabling technologies. I saw today, I think when our colleagues from Penang campus talked about the engineering program, they are teaching most elements of Industry 4.0. But it's our students who get that confidence saying that, look, I got a sample of that. I implemented in my final year project in my subjects, and I'm happy to work with my employee in the future, which you can change. And then I can solve problems. I know how to solve problems. Good engineers make good assumptions, describe the problem and solve the problems. So that's one thing I can advise you. You have every right to be confident, provided that you know what you don't know, and then go on that one and use the techniques you learned. Life is good. You will be very happy when you make progress, when you solve a problem. It will give you more confidence.
Okay, thank you, Prof. Thank you for the sharing. So it's a very good thing. All of us are learning. Actually, the satisfaction that we get when you achieve something or when you solve something, it's unsayable. You can't express that. But once you have that satisfaction in you, then you will move forward. All right. So now let's open from the floor. Any questions from the floor? Yes. You can introduce yourself first.
Hello. Good afternoon. My name is Nina. I'm a student of mechanical engineering. As we know, the advanced media technology has enabled the creation of fake voices, images, and videos that are indistinguishable from what is real. When it is difficult to tell the difference between what is true and what is false, such technology can be used to mislead people in various fraudulent ways. So my question is to IR Chiang. Do you think there is a case for banning certain IR 4.0 technologies even when they may have benefits to offer? That's my question. Thank you.
Oh, wow. Thank you for the question. It's a very interesting one, and one which is pretty close to where I come from. For those of you who do not know, and Prof. Joseph, I come from the broadcast industry, so we deal a lot with audio, visual, and auditory stuff. But a lot of that's behind me, unfortunately, because of all the revolutions, the technology has moved on. But anyway, in answer to your question, I think it's a very topical thing today. I think you young people would know that today there's so much false information out there, even those involving video, image, and data, that sometimes we do not know whether those technologies that can generate all those things and to spread all those things are good or bad. Because I think, I don't have statistics, but certainly I think it's more than half, definitely, of all that stuff out there on the Google. Fortunately, Lawrence looked at the right site and got a good definition for IR 4. Andrew, sorry, for IR 4.0. If you went to the wrong one, you get something which is totally wrong. And if it's wrong, it's okay, because people will sense it straight away. I think the hard part is when it's misleading, where you don't know that it's wrong or it's distorted. So it's a big problem. And I think people in the media industry is now, and social media in particular, is very concerned. How are we going to do it? Because these technologies are used in actually fairly significant societal issues, as in elections, as in marketing for business, and virtually in all aspects of our life. So yes, I've clarified your question, but I've not given an answer because it's difficult. My own immediate reaction to that is essentially you can't stop technology, right? Again, it's controversial. and perhaps other people have got other opinions, which I'd like to hear. You really can't stop technology. We know, for example, that technology used to build weapons, for instance, are bad. I mean, weapons can only be used for killing, and I think most of us would believe that killing for any reason is really not a good thing. And that's why even in Malaysia, we're talking about banning capital punishment. So we have got that problem. How do we do it? We really can't do it. So I think perhaps we have to look for IR 5.0, where we go back towards people themselves in one way or another, where we can have a way of inculcating certain values. I think that's the only best way, because we have got all these negative things that's going on in society. I think with society being around for so many years, we have not been able to solve all those bad things that's happening, the crimes. And so this particular one, which involves technology, I don't think that banning a technology will work. So I can only think of other social engineering methods, which I don't know of any, because I think it's probably, I just heard the word IR 5.0 from Prof yourself, but as you said, it deals with the people factor. And I think that's probably where it's the best place to start. The people factor that hopefully will help to have a method that we can prevent from people from doing all these bad stuff using all these advanced technologies that's available. That's my only comment on that. I really don't have, from what I've read also, I don't really think that that's a major solution, because even major governments like the United States, United Kingdom, and all the advanced countries are trying to tackle that problem, because it's a real big issue. Yeah, but I don't know if some of you might have got some ideas, or I've read somewhere. Perhaps someone in Penang.
Maybe I think Prof has something
I'm
to
happy
say.
to add my view.
Okay, you can.
Look, whatever we do, whatever you practice as engineers in the future has to be ethical. You have to put yourself in place of other people. You have to respect their privacy, their safety, their security. If I give an example from orthotics or prosthetic devices or exoskeletons, you don't want to create superhumans. So there are some devices called exoskeletons, which are support devices you put around your arm, around your back. They were initially proposed to help workers who load and unload baggages at the airports. Of course, now is being used for soldiers who are carrying lots of weapons, loads. The army in US is a big supporter. And at the same time, I know car companies in Hong Kong, in China, in Korea are using exoskeletons to support workers to handle some heavy objects, heavy tools, to extend their life. You see, workers have to be at the center. You can't train qualified people easily. It's not like you put a seat in the field and then 6 months later you got another expert, another engineer, whoever, or operator. So you need to look after your staff. For example, in prosthetic area, prosthetics, of course, is to replace a lost limb. Orthotics area, like exoskeletons, the exoskeleton should be about helping to create normality. Somebody who lost their muscles should get this support, not create a superman, a superwoman or super person, I should say. I have to be very careful. We are not sexiest. There is no, the gender-free language, super person. We don't want it. We don't want any but technology to be used because you have money. You can have this technology to get advantage about others. So it's our responsibility, people we implement. We have to be ethical. Ethics. You need to operate within norms. Is it acceptable? Is it nice? Is it going to hurt this person? So technology has to be ethical. I think this is a very important one. That's an important research topic beyond my areas, but I work with some people with my colleagues. I think we published a paper on these robotic capsules in IEEE proceedings. I think it was in 2020. If you put my name, IEEE proceedings, you can see the ethical implications of using these robotic capsules in human body, because it's somebody's data you are recording. You need to respect that privacy. The hospitals should have very good cybersecurity to make sure that the hospital data is not hacked. And you need to inform them about consequence of this technology. Are you psychologically fit to take this one? Once people swallow, they get worried. What happens if it's stuck in my gastrointestinal tract? What they do, they send a small capsule first. If that comes out safely, meaning that there is no narrow section in your GI tract, then they use this technology. So people are sensitive. People are different. We are all different. So don't make assumptions that something which does not upset me does not upset anybody else. So it's something you have to think beyond, and every technology has to be responsible, has to be ethical. As I told you at the beginning, it has to be socially responsive. I hope I answered something, add something. Thank you very much.
Yes, thank you. Thank you. All right. So maybe we can open for another question. Okay. Yes, from academic staff. Yeah. Yeah, you can use the mic. I did that.
Guys, you study when you are sleeping or lying or on the bus, on the train.
Prof, hiding books is unethical.
I like that. You see, at that time, it's a very nice, naive approach.
Perhaps the moral of the story is when there is an urgent necessity, ethics could be compromised.
Accept this thing. Fighting. Somebody else is fighting. Just admitting. Forgive me. But this is what I'm trying to say. Of course, you have lots of challenges. You have lots of distractions, social media, Twitter, Facebook, all this rubbish. You have to talk with who like your message, who didn't. Forget it.
It's okay, Prof. We are no one's perfect.
Say.
All right. Thank you.
Yeah, good afternoon, Prof. Gusel. My name is Pamish. I'm from the School of Engineering. Okay, I'll put these questions to you, okay, regarding more robotics. Okay, lately, many years back, a few years back, okay, robotics has been the mainstream part of the IR 4.0, which has been a brewing situation where many startup technologies, okay, around the world has been looking at robotics, being in the manufacturing sectors, okay, in many sectors, especially most probably doing a similar job like humans, maybe in the professional area like a chef. Today, we have many startup techs which has commercialized their products, especially like salad making robots. Okay, and if you look at the East in China, they have already a robotics, logistics situations where there is a least dependency on human labor. Okay, so this can be a scare in the society where there could be a loss of jobs for human beings, especially even though it's been told that, okay, it's supposed to be an alternative or assist the humans. But lately there is a striking that it could be taking over the jobs. Okay, in recent years, I think about 2-3 years back, Google also have initiated the autonomous vehicles and so on. Okay, and due to the pandemic, there was a highly dependency on gig economics. Okay, especially the usage of Ubers and Grabs, and this has led to many those who have lost their income or jobs, okay, to depend on this. So with the autonomous driving itself, okay, this could be led to a certain situations. So how do we address this problem in the future where robotics may probably taken over the jobs? Thank you.
Has been around this question for a long time, all the time. But one thing before I answer is robots cannot replace human beings. Don't worry that the robots will take over our universe or our planet. So it is not that simple and easy to replace our brain. So it doesn't matter how fast the computer is, how fast is your artificial intelligent algorithms, which uses 10 years of data or lots of processing. I don't think humans can be replaced, can be overpassed. So I can tell you, somebody who did his PhD many years ago, the progress I see and the intelligence we have cannot be replaced by the machineries. Of course, robots are proposed in the first place to do boring tasks, dangerous tasks. Again, you see, everything is about efficiency, about productivity, again, once more. But it has to be socially responsible. Yes, the number of people working in manufacturing, if you take one company, of course, is reduced. But this technology brings other opportunities. I mean, it's like cybersecurity job. We are talking about artificial intelligence. We are talking about additive manufacturing. We are talking about cloud computing. We are talking about Internet of Things. While some jobs are disappearing, that's quite normal. I can't remember. I mean, some jobs, you can't stop technology. You have to embrace it. But we, not only we, the governments, universities and industry, have to be responsible to upskill the workforce. We have to upskill them. You see, during this COVID, some jobs were, some industries were closed. I don't know, in Malaysia, in Australia, government gave some incentives to some engineers, to some universities to run some professional development courses on various technologies in health sector, in social workers, nursing, in health area during COVID. That was very important. So what I'm saying is, yes, the jobs in that area are cut, but other jobs are created. But another thing some countries are looking at, rather than working 5 days a week, they're planning to work 4 days a week. They found that when the number of work days were reduced by chance in UK, in Finland, the number of divorces decreased. Yeah, number of separations were decreased. People have more time. The crime decreased. And so these are also another consequences. I mean, as a community, fixing mental health is more difficult than employing people, because once your mental health, your well-being is in danger because of overworking or others, it doesn't matter how rich you are. So also, as government and society, we have to look after our people. While some jobs are being cut, some maybe boring, dangerous jobs are cut, new opportunities have to be created. And as a government should look after its people. I mean, why people move to another country? You want better education, health, prosperity for your children, for your family. As long as the government gives this opportunity, create jobs, and make sure that the degrees we are running can provide jobs for our graduates, we shouldn't be afraid of new technologies. But the technology should not be harmful to the community. I mean, like in US, look at the weapons, the guns control. They are saying that all the people who use guns to kill those people had mental issues. But in other countries, like in Australia, there are people with mental health. Guns are banned. So mental health is not the issue. Issue is to access the guns so easily and freely. People are just buying and then using against people. So in that case, they should do something better and ban the guns, because guns are for the wars, and wars are also not good things. The war should be all about to stop the aggressors to attack the other ones. No war is good. There is no winner in any war, by the way. It's all bad for anybody. Hope I answered your question, my colleague. So we shouldn't be afraid of that one. I think there will be other opportunities, better opportunities, maybe prosperity. Then we can work less and be happier.
Hello, thank you, Prof. So maybe can we have a question to Dr. Gomes there? Any question addressed to Dr. Gomes?
Thank you, Dr. Nishata. Otherwise, I look like a backdrop decoration here.
Hello, everybody. I am Eugene Tan from Mechatronical Engineering. Dr. Gomes, can you hear me?
Yes, I can hear you.
My question to you, Dr. Gomes, is that as everybody know, self-driving cars nowadays are involved in some accidents, which can often lead to fatalities. There is a slight growing concern among the people that these self-driving cars can pose a threat to either the drivers of these self-driving cars, the car manufacturers, and even other road users as well. So the main question is, in your opinion, Dr. Gomes, do you think that the accidents caused by these self-driving cars are the responsibility of either the car manufacturer, the driver, or the owner of the car? That's the end of my question.
Okay. Yeah, quite tough. So you want to find who to blame for accidents. All right. I think what you have raised is actually I read an article yesterday actually from US is looking to recall, one of the Tesla model self-driving software. Apparently, just to analyze the number of accidents that is for this particular self-driving car, but then we need to understand one thing in autonomous vehicle, because autonomous vehicle, they have, if I'm not mistaken, there are 5 levels in how autonomous vehicle are being classified, being from 0 until 5. So if you look at autonomous vehicle, they are not actually in the range of 3, 4, and 5. Most of those commercial autonomous vehicle is basically at level 2 and below. Basically, it goes on level 1, which is level 0, which is like the autonomy is not there. Basically, it's full control from the drivers. And then we go on level 1, where some amount of autonomous system or the ADAS system is actually given, where basically most of the control is by the drivers. And then you have the level 2, which is partially automated, but even that, it's not fully automated. So that being said, just based on the article that I read just yesterday, is that if you look at the accident that is represented from or caused by autonomous vehicle, we will see that basically around 60 to 70% of accidents is due to rear end accidents, and then apart from that, 25%, if I'm not mistaken, is what we call as a side sweeping accidents, whereby the vehicle collides from the side, or they call it as a blind spot accident. And another one thing to understand is that since we are talking about autonomous vehicle here, and based on your question, who to blame, we need to understand that the responsibility on road goes to the driver. Even though you are given a technology, how responsible are you to handle this technology? But what I think in terms of autonomous driver consumers or those who purchase those vehicles, their understanding on the level of how the autonomous vehicle work is very important, as to not to assume that it will go 100% autonomous and take the back seat and do whatever that they want to do, as compared to being in the front seat and being aware on the road. So looking at responsibility, I still say the owner of the vehicle has to take some amount of responsibility to make sure that they assert what you call this as control, because even if you talk about artificial intelligence, there are ethics embedded in artificial intelligence, whereby we have safety in design. Then you have, if I'm not mistaken, rules of attribution. Then there is one thing where under the ethics in AI also, the ability to reassert human control, which also means that those particular systems should be able to make sure that at the end of the day, humans are in control with all these kinds of technology. So if you ask me who has in terms of the level of responsibility, I would say the driver has the first responsibility to make sure no accident happens. Second, of course, when we talk about product life cycle, these are all new technologies as per se, because maybe it is going under the innovation, or it's growing, your product life cycle curve, right? It is in the part where it's growing, and autonomous vehicle is looking into like supervised learning, unsupervised learning. At some point is reinforcement learning. So it is learning while it creates mistake and all. It is like a baby while it takes in more knowledge and it learns the environment and all that. And of course, when new technology comes in, the casualty that is involved from this technology sounds to be like a big news. A lot of people tends to put a negative elements to all these kinds of technology. For example, when we, technologies such as vaping, for example, we call that as technology as well, right? Who regulates them? And now the government is looking to regulate them because they don't know where to place this particular technology now. So issues in all these kinds of things in new technologies are normal. But then looking at taking the responsibility, I would say the driver. And then maybe the second thing is maybe car manufacturer, to make sure that, they make sure they improvise the algorithm to learn the environment, or basically to, invest more resources in enhancing their software or scanning technology, to ensure the overall traffic safety. I think, basically that's my opinion, but maybe some other, participant may have different opinions. Yeah.
Okay, thank you, Dr. Gomesh. Right, that was a wonderful input. Okay, I think due to time constraint, can I open one more question from the floor? All right. So maybe from our Penang side, is there any questions from students there? To Prof, maybe?
Okay, Nishata, Dr. Sim here.
Yes, Dr. Sim.
Okay, my student have one question.
Okay, please.
My name is Joe, and I'm from mechatronics engineering. So I have one question to IR Shams. So Industrial Revolution 4.0 had benefits some companies in Malaysia, but we realize that many SME are still struggling on the implementation of 4.0, although our government had introduced some subsidies to help them. So the situation is most of the SME seems to be satisfied to the profitability using labor intensive. But I think this will badly affect our national productivity. So I would like to have your advice to us as a young engineer about this situation. So what can we do, or how we should help the SME to start implementing Industrial Revolution 4.0?
Okay, Ayacha, just make it maybe quick one.
Yeah, I heard my name being mentioned, so I thought I could pass it on to Prof here to do the hard work. But anyway, I'll just offer my very brief comments on that. The line is a bit bad, but I think the gist I got from you is that SMEs have been given incentives to move towards IR 4.0, but they are quite happy to still stick to what they've been doing in terms of what they are doing, which is basically labor intensive operation. I hope I got that question correct. If that's the question, then, well, I do attend a lot of talks and seminars with the various government agencies related to the promotion of IR4. Mainly with MITI, the Ministry of International Trade and Industry, with the Productivity Center and so on. And I think one of the common problems is, I think you don't apply IR 4.0 for the sake of applying IR 4.0. There must be a need to. If your industry does not require or cannot require you, or it's no benefit to go into high tech, that you don't. And I think a lot of our industries are not in a position to. So I think the question should be reversed, that maybe we should be going into industries that can benefit from IR 4.0 rather than sticking to our current industries, which may or may not benefit from IR 4.0. So that's essentially my quick take on it. I don't know, Prof, you probably have a better idea of the global picture. I'm passing the buck to you.
It's better. No, it's not a better answer. Can't be better. Thank you very much for paving the way towards me. Certainly, it should be all need. As I said, the goal of all these revolutions is to increase efficiency and productivity. It's about business sustainability. I talked about expenses and revenues. As a company, you want your revenues should be more than your expenses. So there could be some industries. This is the traditional industry, is labor intensive, still is okay. But they have to be proactive to prepare gradually. If you remember, if I give an example of Japanese film, the photography film, Kodak. Kodak were making those classical rolls for our cameras. And they didn't see that digital cameras were coming. Kodak suddenly disappeared because nobody's buying those cameras anymore. So if you are in a business, you have to see what's coming. While this is from the business end, you have to be proactive what's coming. But at the same time, the technology providers, technology developers like us, we have to demonstrate the benefits of those technologies, raise the awareness, like going to some exhibitions or fairs or whatever. Those technology companies like cobots, cooperative robots, which cooperate to handle some work pieces. You may see some benefits. You need to be convinced. Business people want to see the technology. They don't like PowerPoints, nice talks, dinners, all fine. You need to demonstrate live what technology is doing, how is going to make their business more profitable, efficient, safer. It has to be safer to the workforce. You don't want your workforce to get sick, work in a dusty environment, for example. So in a way, it's a very big thing. You have to raise awareness. You have to train the workforce. You have to demonstrate them. As the technology people, we should demonstrate. You can't simply switch to something with no reason. It will cost you more. You are not prepared. You have to be ready mentally first. For anything, you have to accept it, that I need that. Once you are convinced, then you can go that one. So in that regard, SMEs are hardworking industries. They have to survive. They got tax to pay, salaries to pay. There can be some government incentives for some improvement, for some automation, cost cutting, making them more competitive to bring more jobs and businesses. So it's a very complex problem. It's not that simple, but we have to demonstrate what is the benefit of using this AI or Internet of Things or artificial intelligence or additive manufacturing, cloud computing, Internet of Things, you name it. You have to demonstrate. They have to see them, they will accept. It will take time. So I'm looking forward to coming to Penang on Thursday. We have a panel on this topic. I will be using my same style. I hope there will be some industries who can get something, then we can work with them.
Okay, thank you. Thank you, Prof. Thank you to all panelists for addressing the issue here. I'm really sorry because due to time constraint, we have to stop the Q&A session here. So I'm sure a lot of students have some questions. So maybe you guys can compile the question and pass it to me. I'll pass it to Prof.
But doesn't look like they have questions. They are just listening. If they had it, I don't think I saw the hands are going up. I'm happy to answer your questions, have another hour. So I'm very happy to meet students.
Okay.
Because I feel that I can decrease my age average and because I'm among the young people. So that's always something I like to be with.
It's a great pleasure to have you here, Prof. Okay, just as a concluding question, do you mind sharing with us the uniqueness of engineering programs in UOW Australia? And how can we provide a greater diversification, opportunities to our academicians and students in terms of increasing the mobility of student research collaborations, going across national borders, and enhancing our global experience?
Good. It's too many questions, but I will start with UOW engineering program. If you Google Wollongong, Wollongong is not a city in China. Some people think Wollongong. It's an Aboriginal word meaning a place between mountains and water. So this is the location of Wollongong, 80 kilometers south of Sydney, is on the Pacific Ocean. So our university is just 2-3 kilometers to the ocean. Our second campus in Wollongong is just 500 meters to the ocean. If we have tsunami, one of our campuses will go. It's that flat next to that one. So Wollongong has been manufacturing steel, mining steel, coal mining and steel making. So the only steel company in Australia is in Wollongong. So because of these industries, this university was established 50 years ago as part of University of New South Wales to train metallurgical engineers for BlueScope Steel, we call it. That's the name of steel making factory. So my point is, you need to meet the needs of industry, the employment. And still we have part-time study with that company. They study 6 years. They do their study part-time. During holidays, they work full-time in the company during the holiday. And they complete their project in that company. So the uniqueness of our programs is that we know what the industry needs, where the jobs are. So the employability is very important. That was the first degree. Then we added mechanical engineering. Then we added electrical engineering. And then we add other ones. Recently, we added biomedical engineering. And before we added, we did an employability survey in Australia. Where is the need? Where is the gap in the workforce? So you can't simply open a degree that employability is a problem. And while we are doing this one, our every subject almost in engineering has a laboratory component, hands-on component. We do also train them to have a hands-on component. Another thing we teach them to change their mindset, as I was telling earlier half an hour ago, telling them, look, guys, what we are teaching is just one sample of problems. It's just one scenario you are going to face in future. And you demonstrated how to solve it through lab, through practicals, through industry involvement. And you get this confidence in your students and in industry. And we also got industry advisory board who give us some feedback about how our students are doing. What should be working on? Should we have more practical components, more theoretical? And every student in engineering program has to complete a 12-week professional experience, internship in a company. So in a way, what we are saying, look, we can train the workforce. We can't teach everything, but we teach them the philosophy of like catching a fish. There are thousands of fish species in ocean, in the sea. We teach them to catch a few fish, but they know how to catch other fish. That's the philosophy we are teaching. I think that's the one you have to accept and work on it. We can't teach you something magic that it's always valid. You don't need to read anything else anymore. I hear from some students from different universities, when I graduate, I'm going to throw away my books. Don't do that. You need those books. Just respect it and put it aside. You may forget something. You may not know something. Say, hang on, I'm going to study. I'm going to look at, I will tell you tomorrow. There is nothing wrong with that. I can't remember everything. Can't remember everything. So that's what our uniqueness is. Industry driven, employability driven. And we got feedback and we got practical component. It takes time. There is no magic formula. And I spent 4 of my academic visits in Switzerland, in EPFL. This is in the top 50. In China, in City University of Hong Kong, University of British Columbia, in Vancouver, Canada. I was able to compare our programs with theirs. There is no difference. There is no difference. It's something else ranking them higher than us. We are following the same principles, lectures, practicals, confidence, teaching them techniques, teaching them how to communicate, how to get that professional confidence in them. That is the key. There is no any other magic formula. Believe me, you can be challenging all these people from those other big universities by graduating from UOWMKDU. You can do that. We know that. We will help you. So the programs you have here are good as in other places. The problem is your confidence, believing in yourself. And we need to change our mindset, saying that, look, yes, there is a gap. Yes, I don't have luxurious maybe labs or buildings or reputation, but I have the heart and mind to solve the problems. I think this is the uniqueness of that one. For our colleagues, of course, the same thing. You have to balance your life between teaching and learning as well as research. And you have to cooperate, collaborate. It's time to cooperate. You can compete to do better, to increase your performance, but rather than competing with your colleague in the same institution, in other institution, collaborate. 1 + 1 is more than 2. So that is the time to cooperate, collaborate, and be open to other ideas and other cultures and share. That would be my suggestion.
Okay, thank you. Thank you so much, Prof, for your valuable input. Thank you to all the panelists for your participants in the dialogue session today. So I will pass back to the MC today. Thank you so much, Prof. Grusi. Thank you so much, IR Chang. Thank you, Dr. Gomash. Yeah. Yes, sure. So,
grandchildren.
All right, signing off here, Dr. Nisha from UOW School of Engineering, UOWMKDU University. Thank you, Prof.
Okay, thank you very much, Dr. Nishata and all panelists, as well as for the engaging session today. I hope everyone here gained some new knowledge from the forum, and we can use them as reference in our work and studies.